All right, lesson number 3 in the permutations and combinations section. We're actually going to talk about what a permutation is. And there's a reason why we did fundamental counting principle first. You're going to see a lot of similarities. But basically a permutation is the number of ways, or permutations are the number of ways to put any number of unique objects in some sort of order. Okay, so unique means that like A and B are different, but A and A, those ones are not unique. So if we switch the positions of those, then it wouldn't change anything. So that's why we have to put that unique disclaimer in. Okay, so a different order means that you have created another permutation. So A versus, like AB versus BA means that that is a different combination, right? Because those two are unique. AA versus AA, if we swapped where the A's are, that wouldn't be different, so this would not be a different permutation. Okay, so it depends on whether or not those things are unique. So permutations can be calculated using the formula NPR, so it's N permutation R, equals N factorial over N minus R factorial, where N is the number of distinct objects, and then R is the number of times that objects are being selected. Okay, so if you have 8 things to choose from and you're only picking 5, that would mean N is 8 and R is 5. And we'll see that as we keep going. So always remember, if we're doing a permutation, order matters. The order that we line people up for a photo, if we switch 2 people, that changes the photo, right? The A versus B, or AB versus BA, that's a different combination. Order matters. Okay, so some examples here. So how many 5-digit numbers can be made from the digits 2, 3, 4, 7, and 9 if no digit can be repeated? Okay, so again, we talked about this the last couple days. If we can't repeat, that means once we've used something, it's off the table, it can't be used again. Okay, so if we use fundamental counting principle, which I know we have already gotten used to, if we think about, okay, we have 5 digits, right? How many 5-digit numbers, we need to fill all 5 spots, can be used if we're only using these digits. So the first one, we'd have 5 options, right? And then whichever one we pick doesn't really matter. Now we only have 4 options. Then again, we only have 3, then 2, then 1. So we talked about how the fundamental counting principle can often be represented in factorial notation. So this is 5 times 4 times 3 times 2 times 1. And then we can use that on our calculator to calculate that more quickly than typing in 5 times 4 times 3 times 2 times 1. Though with a number that small, it might just be easier to type this. If we want to use permutation, okay, so we have 5 things to pick from. So if we start with that NPR formula, because we have 5 things to pick from, our N is going to be 5. Because we're going to choose all 5 of them, our R is also 5. So that means that we would be, our permutation format would be 5 permutation 5. I often say it as 5 pick 5, and tomorrow we're going to talk about 5 choose 5. That's a combination. Again, this stands for permutation, but just the way that I speak about it is pick, because it's much faster. So I don't have my calculator with me, so I can't actually show you how to get to this, but if you press math and then you scroll over 3 times again to that PRB, right? Just like we did when we were looking for that factorial notation. So math, scroll over 3 times to get to, that's going to get you to probability functions. The second one is NPR. So how you'd have to enter that in your calculator, depending on how new your calculator is if you have a new calculator, you'll pick math, scroll over 3 times, press number 2 for NPR, and it'll show up as like a little box, P little box, and you can scroll back and enter your numbers in the box. If you have an older calculator, you're gonna have to click 5 first, then do this, and then click another 5. So it would look more like in your calculator, you'd enter kind of like that, okay, as opposed to the box. Okay, so if we type that in, we end up getting 120, because what this is doing is it's doing 5 times 4 times 3 times 2 times 1 for us, okay? It's entering these numbers into this formula up here, so this is going to be a 5 factorial divided by 5 minus 5. It's a 0 factorial. One thing to note here, that 0 factorial is equal to 1. That is just something that you guys don't need to know the like foundations underneath of or why that is, but I want to point it out here because otherwise we would have 0 minus 0. If that was still 0, we'd divide by 0, and we know we can't do that in math. So 0 factorial is 1. If you want to know more about that, you can Google it or ask me or whatever, but it's going to be 5 times 4 times 3 times 2 times 1 on the top divided by 1, so that's how we get this. Okay, so same thing, 2 different ways to get to the same number. Okay, so how many two-digit numbers can be made from these 5 digits if no digit can be repeated? So again, if we start with the fundamental counting principle, we're going to have just 2 spots to fill this time. We have 5 options for the first one, and then 4 options for the second one. So that would be 20 options. If we use our permutation this time, our n is 5, and this time, because we have 5 options to choose from, our r, the things that we're actually choosing, is only 2. We're only picking 2 things. So it's going to be 5p2, okay? So if we punch that into our calculator, we're going to get that same number, 20, okay? The reason why that works based on the formula, again, so if we have, I'll do it down here, so 5 factorial divided by, it's n minus r, so 5 minus 2 factorial, that's 5 factorial over 3 factorial. We talked about how yesterday that would be 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. These 3 2 1s would cancel out. We just get left with 5 times 4. We know that that equals 20. Okay, so 2 different ways to get to the same thing. Okay. Okay. How many ways can 4 distinct cars and 3 distinct trucks? So maybe there's like a silver, a black, a blue, and a red, and same deal, so they're different, and distinct is important here, right? Because we talked about unique objects. If they were all the same truck, if they were all like silver Toyota Tundras or whatever, then that wouldn't be distinct. Okay, we wouldn't be able to tell, and it wouldn't actually make a difference in our permutation. So that distinct is a key word here. And once you know how to do combinations tomorrow, you're gonna have to pay more attention to that. But that distinct tells us, okay, it matters. So for the trucks, if the trucks must be together, this is one of those situations where we're gonna group the trucks. The trucks are gonna be like truck, truck, truck all together, and then they're gonna move as a package deal. Because those 3 trucks are different, then within those 3 trucks, we have 3 to pick from. We have to pick all 3, and so this is equal to 6. So you can punch that into your calculator, or do 3 times 2 times 1, either way, okay? Then we do all the things together, okay? So we're gonna have 4 cars that we can move around as individuals, and then that package deal of trucks. So now we have 5 objects, and we need to pick an order for all 5 of them to line up. Okay, so this one, again, if we punch that into our calculator, it's gonna be 120. And when we had situations like this the last couple of days, remember that if we change this or this, it's gonna impact the whole order. We're gonna have to multiply them. So we're gonna have 3 pick 3 times 5 pick 5, which is 6 times 120, which is 720, okay? Just so you guys know, especially depending on the situation, sometimes these numbers just get stupid big. So if you want to leave it like that, that's okay. Obviously, if it's like a numeric response, something like that, you'd want to calculate it. But if it's a written question, that is a viable answer, okay? Unless it specifies calculate the number, you can leave it like this. How many ways can 31 graduates line up to enter the auditorium? So as soon as one person trades with somebody else, that's a new combination. So this would be, there's 31 people, and all 31 of them need to be in that permutation, be in that order. And as soon as two switch places, that's an entirely new order. So if you guys were to punch this in your calculator, you'd get about 8.22 times 10 to the 33. So that's a massive number. This is huge. Okay. So if you have a question like this, it's going to flood your calculator. So again, that is fully appropriate. Okay, 31p, 31. How many ways can 31 graduates enter the auditorium if the girls enter first and then the 16 boys follow? Okay, so that would mean that we're going to have the 15 girls and we're going to pick the order for them. And then we're going to have the 16 boys, and we're going to pick the order for them. And because if one of these changes, it's going to change the whole thing, we have to multiply those two things. Okay, so again, these numbers are going to be super huge. Okay, so this is equal to a smaller number, but still very large. Okay, so it's a smaller number than what we had up here, but it's still a very big number. So no wonder we do it alphabetically, right? Because then it kind of makes it less predictable. How many different ways can 31 graduates enter the auditorium in alphabetical order? Only one way, because then it's prescribed. So again, no wonder we do it like that, right? You can only have one alphabetical order combination. Okay, write an expression for each using factorial notation. Okay, so this time we're gonna use that that formula that it gives us. So a couple pages ago, again, it's NPR equals n factorial over n minus, r factorial. Okay, and this is on your formula sheet, by the way. You don't need to memorize this. Okay, so it's going to be n is 8, so this is going to be 8 factorial divided by 8 minus, and because r is still unknown, we're just going to leave it like that. Okay, so that's how we would write this in factorial notation. 8 factorial divided by 8 minus whatever r is. Same deal here, our n has to stay as a variable, we don't know what that is, and then we're going to have n minus 5 factorial. Okay, so and we're going to practice using the formula a little bit more later on. We're going to express 501 times 500 times 499 times 498 in this form. Okay, so the fact that we're starting at 501, that means that whatever we're selecting, there was 501 options to start with. So what this tells me is that n is equal to 501. The fact that we have 4 things picking, that means that r, we are picking 4 objects. Okay, so in this form, it would be 501. Oops, I always do that. I start drawing my p too early. 501, p, 4. If we think about that as far as the formula goes, that would be 501 divided by 501 minus 4 would be 497 factorial. And again, if we think back to Friday's lesson, this is 501 times 500 times 499 times 498 times 497, and at that point, if we just leave that as the factorial notation, these guys are going to cancel, and that's how we would get back to this. Okay, so you can always check your work on a question like that. Okay, next one, we're going to solve for the variable. So we're going to actually find out how many, if we have n options, what that n has to be to say if we're picking 2, we have 56 combinations, 56 permutations, because order matters. We can't call it a combination, that's tomorrow. So we're going to use the formula. We're going to say n factorial over n minus r, so n minus 2 factorial has to equal that 56. And what we want to do here is solve for n. So to solve for n, we need to get rid of the factorials. Yesterday or on Friday, we talked about how if we take whichever number is bigger, so in this case that's going to be n, and start expanding it out, we're going to have n times n minus 1 times n minus 2, and at that point we're going to leave it as that factorial, because then my factorials are going to cancel out. And then I still have that being equal to 56. Okay, so what this is going to do is generate a quadratic for us. So I'm going to distribute this n in, so we're going to have n squared minus n. I'm going to move the 56 over, so minus 56 is equal to 0. Okay, and if it takes you a couple extra steps to like simplify, like distribute that in, move this over, that's okay. I just don't have a ton of room here. When we have a quadratic, we factor. So in this case, it's going to be n times n. To get that n squared, we need two numbers that multiply to negative 56 and add to negative 1. So negative 8 and positive 7. So from that, n, right, if that thing is equal to 0, either this has to be equal to 0, so n would have to equal 8, or n plus 7 would have to equal 0. So to do that, n would have to equal negative 7. If we're saying n is the number of things that we have to choose from, the number of choices we have for that original whatever, if it's toppings on a pizza or letters to put first or whatever, to say we have negative 7 things to choose from, this just doesn't make sense. So we're going to just say that this is n equals 8, because that positive number makes sense, whereas the negative doesn't. Okay, this other one, similar but different. We've got np6, so n is our unknown, and then r is 6. Okay, so we're going to expand this into the formula. So n factorial over n minus r factorial equals to 5 times n factorial over n minus 5. I'm going to put extra brackets in there, n minus 5 factorial. Those aren't extra brackets, they're needed. Just seems like a lot. So now we have n factorial and n factorial on the top. These are both factors. They're both being multiplied or divided by everything in their side, right? It's 5 times n factorial divided by this whole thing. So because they're both factors, they can cancel right away. So what that leaves us with is 1 over n minus 6. And I'm not going to write that quite yet because I want to look at, okay, what else we have left. Because we have two that are close, we have to think, okay, which one can I expand to get these factorials to cancel out? So again, we want to expand the bigger number. This one, n minus 5, would actually be bigger, right? Like let's say n is 20. This would be 15 factorial, this would be 14 factorial. So we want to start expanding this bigger one. So I'm going to leave n minus 6 factorial. Then we have 5 over n minus 5. The number below it is n minus 6, and that's where we're going to stop because now my n minus 6 factorials are going to cancel. So what I have is 1 equals 5 divided by n minus 5. So I'm going to multiply both sides by that n minus 5. So you can write it if you want, n minus 5, because then these guys are going to cancel. I'm going to get my variable up in the top of the expression, which is what I want. So I have n minus 5 on this side equals 5. If I move that 5 over, I have n is equal to 10. A good way to check your work on this is to actually go back and say, okay, 10 pick 6, what's that equal to? Does it equal 10 pick 5 times 5, right? Same deal here. You can actually check these things on your calculator and make sure that you've done them right. The last thing that we want to talk about today is permutations with non-distinct objects. So what happens when there's two trucks that are the same color, the same make, the same model, the same year, whatever, and switching their spot doesn't actually change the combination, okay? It doesn't actually change that permutation, that ordering of things, okay? So the formula to calculate the number of permutations where objects are not distinct is, we're still going to start with n factorial, so the total number of objects factorial, divided by a factorial, b factorial, sometimes c, d, whatever factorial, where n is the total number of objects, and a, b, c, etc. represent the number of times an object is repeated. So we're going to look at a couple examples, and this formula will make sense. So remember, we've got n factorial over a factorial b factorial dot, 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 dot. How many arrangements can be made using all the letters of each word? Okay, so first thing that we're going to do is say, okay, we have 1, 2, 3, 4, 5, 6, 7, 8 total letters. So this is going to be 8 factorial because that's the total number. Remember, we're using all of them, so we're going to be picking all 8. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then we want to look at, okay, do we have repetition? So in Victoria, we have 2 i's. So what that means is we have to divide by 2 factorial to represent the fact that if I switch the places of those i's, it doesn't actually make a new word. Or sometimes we use word with like the air quotes to say like it's a combination of letters, not necessarily a word. It may not be in the dictionary, but we're still going to call it a permutation. Okay, another way that we could write this is 8 pick 8, so we could write it using permutation notation divided by that 2 factorial to represent that repetition. Either works. I tend to lean towards this one, but if you gave me this one, that is the same thing. Okay, Abbotsford, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total, so 10 factorial over, this time we have 2 B's and 2 O's, and then everything else is unique, right? We have an A, T, S, F, R, D. Okay, so that means we have 2 B's divided by 2 factorial and 2 O's divided by 2 factorial. So because those things are not the same, right, just because we have 4 things that are repetitions doesn't mean we're dividing by 4 factorial. We're going to do the B's together as a package deal and the O's together as a package deal, which is why it's A factorial, B factorial, C factorial. You'll see sometimes it's lots. Another way to write this would be 10p10 over 2 factorial, 2 factorial. Okay, so either one of these is perfectly acceptable. So both are acceptable. And again, you don't actually have to calculate. An actual number. This is a very valid answer. So a lacrosse team's record over a season was 15 wins, 4 losses, and 2 ties. So the first thing that we want to think about is how many total games. 15 plus 4 is 19 plus another 2, so 21 total games. Okay, so on their record, they would just see, like, let's say they won, lost, won, tie, won, lost, won, right? It doesn't really matter if I switch the W's around. Okay, so these wins are all non-distinct. They're not unique, right? A win is a win on their record. Okay, ... That obviously wasn't all of them. Same with the losses, right? We can switch the places of those 2 L's and it doesn't change the order that this could have happened. Okay, so what that means is we need to take the 21 games, those 21 total different things, and divide by the repetition. So we have 15 W's that could all interchange spots and not change things. We have 4 L's that could all change spots and not change things, and then 2 ties. Okay, so again, if you prefer 21p21 to say, okay, here's the total combination of, or total permutation of all the games, then 15 factorial, 4 factorial, 2 factorial. So again, that would be wins, losses, ties, if you want to make a little note for yourself. And again, you don't have to calculate that. If we know that the team started out the season strongly with 5 straight wins, how many orders are possible for the team's results after that? So we want to say, okay, the first 5 were all wins, then the rest, so the remaining 16 games are still a mystery. So if we think about that, we still have 11 wins left, 4 losses, and 2 ties. There's only one, only one option for 5 wins in a row, right? This is just, there's one way to do that. So we're going to say there's one way to have those first 5 games all be wins, and then we're going to multiply by the combinations, or the permutations we can get for the rest of the games. So we have 16 factorial games divided by the 11 repeat wins, 4 repeat losses, and 2 repeat ties. Okay, so because we only have one option here, we would generally not write that, and this would be our answer. 16 factorial for the remaining games divided by 11 factorial wins, 4 factorial losses, 2 factorial ties. Okay. And then we can also put more restrictions on here. So we talked the other day about restrictions on situations. We can do that here too when we have repetitions. So determine the number of arrangements in the word tattoo. Okay, so we've got 6 total letters. We have 2 O's and 3 T's. Okay, so if it has to begin with an O, then what this means, if we think about, okay, here's my spots for my 6 letters. Boop, boop, boop. There's 2 options for that first letter to be an O, because there's 2 O's. Then the rest are just going to be, there's 5 options left, then 4, then 3, then 2, then 1. Okay, so we could write this as 2 times 5 factorial. Because we have repetitions, we need to divide by the fact that there's 2 O's and 3 T's. So I like to think about it as normal with whatever constraints there are, and then always just divide by our factorial of repetitions. Okay, so this one, again, if you want to make a note, has to be an O. So it's a 2 because there's 2 options for 2. There's 2 different O's. And think of them as Scrabble tiles. Okay, how many ways can we arrange the letters in the word reindeer if the R's cannot be together? So anytime we have one of these like cannot be together, the easiest way in my mind to do this, I've laid out in different steps, okay? And this is not always going to be here, like the diploma will not give you these steps, but it's something that I find helpful to learn the strategy. So step 1, we're going to figure out the total number of arrangements. Step 2, we're going to figure out the number of ways that the R's are together, because it's easier to group something together as opposed to saying we have to keep them apart. Then we're going to do the not together is equal to total minus where they are together. So this will be total options minus where they are together. That's going to give us all the situations where they're not together. Okay, so we use this strategy a bunch. So number of total arrangements, we have 1, 2, 3, 4, 5, 6, 7, 8 letters, so 8 factorial, divided by, we've got 3 E's and 2 R's. So we have to divide by 3 factorial, 2 factorial. Okay, so there's our number of total arrangements. And if you guys are doing this on your calculator, make sure you type it as 8 factorial divided by bracket 3 factorial, 2 factorial, as opposed to 8 factorial divided by 3 factorial, 2 factorial, or times 2 factorial, because your calculator is going to follow BEDMAS, right? So if it does this, it's going to say 8 divided by 3 factorial, and do that, and then it's going to multiply this whole thing by that if you don't put those brackets there. Or I guess that would be this situation. 8 divided by 3 factorial, then it's going to multiply by this. So the brackets here are really important to make sure you're dividing by both of those things, okay? Which is why sometimes it's easier to just leave it like this, because then you don't have to worry about calculator errors. Okay, so then we're going to look at the number of ways that the R's can be together. So we're going to group the R's. Okay, so we've got RR as one Scrabble tile, and then we've got 3 E's, an N, a D, and an I think. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's all my letters. The R's are in a group together. Okay, so in this situation, normally we'd say, okay, how many different ways can we combine the ones that just have to be together? But there's only one permutation here, right? Because if we switch the R with the other R, it's still the same thing. The R's are identical, they are not different. So there's only one option here. So we don't actually have to multiply by the number of options where the R's are together, because there's only one, and 1 times anything is itself. So we've got 1, 2, 3, 4, 5, 6, 7 total things now to arrange, divided by, we've got that 3 factorial combinations here, okay? Another way that we could look at it is normally we'd say there's 2 factorial ways to arrange the r's, and then 7 factorial ways to arrange everything else, divided by the 2 factorial for the r repetition and the 3 factorial for the e repetition. These 2 factorials would cancel, okay? So either way you want to think about it, that would work. Okay, I'm going to move forward with this because it's simpler. Then the situation where they're not together is the total. So 8 factorial divided by 2 factorial, 3 factorial, minus 7 factorial over 3 factorial. Okay, so if this was a written question, this is totally sufficient. If it had to go in like a numeric response box, you would actually have to type this out into your calculator, in which case those brackets here are very important. Okay, but if this was just written or on your assignment or on a quiz or whatever, and it's not numeric, then this is totally fine. Okay, so practice for today. It's a long section. This was a longer lesson, so there's a good number of pages. It's just helpful to see the other examples, so go look through that and then do numbers 1 through 10 on page 152, 153. As always, let me know if you have any questions.